You took your notes last night, correct, guys? So since you took your notes last night, if you have room on your notes from last night, draw a line, okay? We are going at page 82 first. And we're going to go through just checking to see what exactly it was talking about. And if I look on here, the only problems that I have are just the formula of assessments. Is everybody there? Okay, so that's what you're looking at right now, is the formative assessments. Look them over. Okay, so I'm going to go over the information that I have written on my one pager today, and I just want to make sure you have what you need to know. And then plus we want to talk about how to do the vectors, okay, because you're going to have to do them in the lab. So the first thing that I have written down on my notes is what a scalar quantity is. What is a scalar quantity?
That has magnitude, no direction.
Right. Has magnitude, but no direction. So when we're talking about something that's scalar, what have we done so far that was scalar? Speed. Right. Right? We were trying to calculate that. We didn't use a vector when we did that. This is our first day of using vectors, correct? Okay. The next thing I did was I wrote down what a vector was, which we talked about before, which has magnitude and direction. We also talked about the length of the arrow tells us the magnitude, and then the direction shows us where the arrow is pointed to. Okay, everybody good so far? Then we talked about, give you an example. So let's do an example. Say in our book, it showed one. Let's say that we have a friend, okay, and we have our house, and we have a school, okay? So what we're going to say is that we left our house. First thing you'll need to do is do your north, south, east, and west, because that is going to be important just in case. I always draw mine, so I'll make sure I know which direction I'm going in. Okay? So I'm saying that I have left my house and I am going to my friend's house. Okay? Yes, ma'am. Once I'm at my friend's house, I leave my friend's house and we go to school together. Okay? Now, if you look in the book, it shows you this scenario, except mine is in the opposite direction. So it says graphical method of addition. The student walks from his house to his friend's house and then to his friend's house to the school. The student's resultant displacement can be found by using a ruler and a protractor. And what they've done is they've done a dot from here to there. Correct, everyone? I'm getting y'all a ruler guide. That's what I'm trying to do right now. Well, there's what you have to do back in the lab to do it with. But anyway. Okay. All right. So first of all, if we just go ahead and do some math, right? Say that from my friend's house, my house to my friend's is 1 1/2 miles. Okay. And if I say from my friend's house to the school is 2.5 miles. And I'm going to say from the school to my house is 2.5 miles. What is the total distance that I had traveled? I went from here to his house to school to back to home. So how many is that? 6.5 miles. So that's my distance. What is my displacement when we got done? 0. Okay. Now, how many miles did my friend travel to school and back? 5, right? 2.5 there, 2.5 back. Okay. So we kind of got that information, correct? But let's think about this here. If we're talking about what would happen in the scenario if I left my house and I got halfway there, I had to turn back to get something, then I had to go back to my friend's house, and then to school, and then home. What is my total miles then? So you told me it was 6.5 miles that I went, but now how many miles have I gone?
7.25. I don't know.
Well, we know it's 6.5, right?
Are you thinking?
You got to know these numbers here, though, don't you?
Hold on.
You got to have these numbers. I said halfway. What is halfway of 1.5 miles?
0.75.
0.75.
Is it?
0.75. Okay? So we got 7.75 and 0.75. If you add those together, how much is that? 1.5. So what is the total miles that I've had? That I traveled now? 8 miles. How about my friend? How many miles has he traveled? To school. He didn't change, did he? Okay. How about my total displacement? Hasn't changed. So do you understand where vectors are important and how you can illustrate what's going on? You got it. Okay. Now, when we're talking about, what did I say about vectors going in opposite directions? What do? Subtract them. Okay. Does that apply here? No, not for not for his complete walk. Is everybody good so far? All right. So let's look and see what else Miss Sloan's got. So then it tells us of a triangular method. Are you ready? Did you write that down in your book? Your ISN, triangular method. I need it black because I don't have it. So when we're using a triangular method, what we're going to do is we're going to have, and I've got to find this, guys, so it's my fault. You have your ruler that does your displacement. You have your protractor that you're going to use here that shows your direction. Okay, so let's just keep this in mind. So if, for example, they gave us a AB plus BC yields AC. Do you see that in your book? In your reading assignment, what did that talk about? gonna give you a few minutes just to read it over. Miss Love goes and tries to find that. Read on page 84 for a minute, please, while I look for my protractors. Yeah, you know those little funny looking things? Hit on the back. That's three. Okay. So it says here, the triangular method of addition, the resulting vector A of a toy car moving at a velocity of 0.8 meters per second across a walkway with a velocity of 1.5 meters per second can be found by using a ruler and a protractor. So what they were doing here is they were saying this right here is the car. Okay. What you're going to do is you're going to put your protractor, where are you going to put your protractor at? In that corner. In which direction? Like this, right? So your protractor is going to be in this direction here. And then what are you going to do? Use your ruler here. What's that going to help with? While you're thinking about that, I'm going to find the protractors and rulers so we can practice. There's 2. There's 3. Who doesn't have one? They'll be leaving these on the desk. You can have them.
Are you coming?
Oh no, I'm too short. All right, do you have your protractor where you're supposed to have it? Class? I have to find you some more rulers. But then what I want you to try to do is once I get you the rulers, I want you to do it, the what's on the book that it's asking for, because we're gonna do some problems. Give me another second to find the rest of the rulers. You didn't go joking, did you? You think you better go ask? All right. All right, so you have your protractor and your ruler. Put your protractor where it says for you to do. Put your ruler where it says that it needs to be. I wrote mine on my paper.
My drawing is tiny.
Sure.
My drawing is small. Mine clearly is straight. Yeah, look. Yeah. How do you know this?
What you mean?
All right, so what was it?
70
70 what?
degrees.
Degrees? What's the length of it though? That's what the ruler's supposed to be for.
Oh,
Mine is
my ruler don't reach the end of the line.
Okay.
Let's just say 31 centimeters.
31 centimeters and 30 degrees, right?
70 degrees.
70 degrees. Okay, thanks, sir.
We're doing 7 centimeters. Can we just do yours to around down?
Well, this is what I want you to do. I want you to draw one on your paper and practice using the ruler. Okay, are you ready? Let's draw one that you can measure.
But that's not taking.
You have the whole book.
Well, how big does it have to be?
Okay, so you said, sir, it was 70 degrees? Is that what you said? 70 degrees, and what was your measurement that you thought you had?
31 centimeters.
31 centimeters. Let's go. Okay, so are you ready, Tanya?
Yes.
Look at the book, the textbook.
You know what, this,
It's the same thing.
I got it. You want us in centimeters or inches?
Either one.
Well, I would have done it. I know.
That's why I said, needless to say, that's why I said either one, because I know there's some of you that don't have it.
You're telling me that was 70 degrees.
Mine was 70 degrees, and I told you to draw yours at 70 degrees and 31 centimeters, please.
This ain't even as big as the book. Okay, that works for me. Right, are we supposed to?
Wanting you inside, ladies, I'm wanting you to draw me a scenario, please, ma'am, that is a 70-degree angle and is 12 centimeters long as the resultant vector. Okay. So the first thing I've asked you to do was draw that. Is everybody ready?
Yes.
I also was hoping that you drew this in your book as the example. Okay? Once you get that done, what I want you to do is you should have your resultant vector, right? Like I asked you to have, correct?
Yeah.
Okay. The next thing I would like you to do is I would like you to draw your vectors going this way and this way. And I want you to tell me what is the measurement. I'm coming by to look.
Who is supposed to do it?
I asked you to get your point on the bottom and find the degree, which is 70 degrees. You should take your ruler from there,
Okay.
from there. Before you line. That's what I want you to do.
Hold on, this one don't.
All right, how are we doing?
That angle.
Oh, duh. One here, there. Okay. Oh, that's right. You have one on hers. I was talking about somebody else.
You can move it.
Once you get it, once you get it set, move it and draw it. All right, there's that. All right, so you have it, and I've already done.
Oh,
So then what I want you to do is I want, this is the result, okay? We just got things here, it's fine. And draw your line up to the next step. That's exactly what I want. And this way it would come. You got yours. You got yours. You're drawing yours. You're done with yours. You're done with yours. So this right here, very good. Yeah, it's right. It's good. No.
I'm scared.
So is that yours? Okay. So tweet. Yeah. So. First white man. Example like this. Chris, and like this. So the last thing that you want to do is, do you have your A, B, and C written on your example? Okay. So your A is here, okay? Your B is here, and your C is here. Okay? The number that it says here is, it says the vector of AB, okay? AB should plus BC should equal AC. Do you see it? Do you see where it's talking about from here? A, B, plus B, C should equal A, C. It is exactly that. Okay. Now, in this scenario, are you ready? In this scenario, we had 0.8 meters per second and then 1.5. Do you see that this right here was the velocity of the car we had on this one right here? That was our vector for that. This is the vector walkway, is where the car was going down the road. And we were trying to find the displacement. Is everybody good so far? So how would we do the math for that using this scenario?
So it's A, B.
You gotta find A.
We have to find A first. Now we have B and we have C, right?
Yeah.
How do we find A? A is the displacement.
0.5 minus 0.8.
Okay, and what do you get?
No, because shouldn't A be the
So what do we get? What number do you get? That's what he's saying. It's what he says right now. 0.7. Okay, are you ready? 0.7. What is my units of measurement? Meters per second, right? So can we have that and plug this in to check it? Based on what you said. So it says A times B, right? That's 0.7 times 0.8, right?
0.52.
Okay, we're going to add that to 0.8 times 1.5. What is your AC then? So 0.7 times 0.8 plus 0.8 times 1.5, what number do you get?
1.76.
So basically what you're saying is, that makes sense to me.
Is it right?
I don't know.
I don't think it is.
Okay?
That would be a little number, that would be a little number, and that would make a little.
So,
What the A times C is the same. Yes, that's not.
yeah, that's logical though, right? Because you tried that. All right, those of you in the back, come on over. We will continue this tomorrow, guys.
What do we say?
You need to take your ISM book, your computer, and your calculator. And I think that's it. Leave everything else behind.
Here, Josh.
All right, so guys that are at home, what I want to do is I want you to take you to Google Classroom. If you go to the agenda, and you go to today's assignment. So what we did is we kind of went over the direct instruction, where we went over maybe a sample math problem. And then as you can see, here's a small group, which is a vector addition and worksheet. Since this is something that we're not using equipment for, this is going to be online, so you'll have to choose those. So the first thing you'll want to do is you want to open up the worksheet. So you'll click that and open it up. The next thing that you'll do is you'll go back and you'll go to the vector addition and you'll click that and you'll open that up. Now, if you're having problems with the FET, what you'll need to do is you will need to open up Clever first to do that. Okay. So what you're going to do is you're going to use this activity. You're going to do what it's asking you to do. And then you're going to write this in your ISM book and submit this along with your one pager and any notes that you took on this assignment today.
I did it earlier, but I